Hi, my name is Ashwin. I'm going to explain a topic called indexing and a subject called file structures. Let us first know what file structure is and how our topic of indexing makes sense in this context. In a crude way of talking about file structures, I would say it is the way the file and data is organized in a disk so that the data can be accessed in the most efficient way. Indexing is just one of the ways of organizing and accessing data from the files. Let us try to understand why we need indexing. I'll give you an example. Consider this. We have 1000 students in a university, each with their own data. The university has the task of organizing the data in their server. Let us just say the university has kept all the records of the students in a random order. Now if we want to access a student detail, we can start from the first student record and go on until we find the desired record. It is a highly insufficient process which in the worst case needs big O of n comparison. To overcome this, the university can try to sort all the records. To sort all the records, it needs to be brought in the main memory. Most often than not, the records will be larger than the available space in the main memory. So this method is insufficient for even moderately large files. So there comes the need for indexing. The 5 books are present in the hard disk. 100, 600, 300, 500 and 400 are the address of the books present in the hard disk. A, D, B, C, C are the name of the books, which are not at all unique. 1, 5, 2, 4, 3 are the numbers which are unique for each and every book. And we have the main memory. As we can see, we cannot fit all the books in the main memory, and we can see 1, 5, 2, 4, 3 are not in a sorted manner. We can use indexing. Now map the numbers with the address. Say 1 with address of 100, 5 with address of 600 and so on. Now we sort this and keep it in the main memory. Now say we want to search the book number 4. We go to the main memory where the list is present and perform binary search. Binary search is nothing but we divide the cards into two equal parts and the mid card is compared with the card which we require. Say for example we have 5 cards and the required number is 4. We first perform binary search with the 5 cards and divide into two equal parts, 3 being the mid card and 4 the required card. We compare it as 1, 2, 3 is carded and we are left out with 4 and 5. Now binary search is performed on 4 and 5 and we get the answer. Now as we got the address, we can access to the address and we can check on the book.
Your continuation.
This is called primary index. Now not everyone searches books with numbers only. Few people search with names. For that we need secondary index. Now we map the name with the number, not with address, as the name is not unique. Say A with 1, D with 5 and so on. Now we sort the list and keep it in the main memory. Now say we want to access the book B. We go to the main memory and perform binary search. After finding the number, we again access the primary index list. And now after accessing the primary index list, we get the address. Now we access the book 2, which has address 300. This is called secondary index. There are three ways to implement secondary indexing. One is using buckets. Here we are giving each name a fixed step of holders called buckets. For example, each name is given 3 holders to store 3 primary indexes. But the problem is, what if the same name needs to store 4th primary index? To solve this, we can use inverted list. In inverted list, we given each name a linked list so that it can grow dynamically. So the third approach is to have a place to store the primary index and using linked list to link them to the particular names. Thank you.